Hello.
Hey guys, how are you?
Hi.
Let's wait for a few minutes.
Sure.
So Jita, have you landed the GC stuff?
There is one operator API change that has not been landed yet, but I think we have the change itself is very short. There is a one-liner bug fix that's being sent out last night.
Oh, okay.
Yeah. Other than that,
cool.
I think the auto GC in agent, I guess Gilbert should be working on that.
Yeah, I think that's what he's working on right now.
Okay.
Can you like share your screen, like open the talk? Sorry, you're muted.
Yes, let me do that.
Yeah.
Is this visible?
Yeah. Yeah, let's wait for 1 more minute and then get started. I mean, some folks might be late. Just not wait for them. All right, so Jita, I think let's get started. So can you tell me a little bit like what you plan to do?
I am trying to use this time to decide what to do. I think I lay out the two designs here. I actually don't have strong opinion on either of them. I just want to see whether
what's the motivation? Like what's the high level like goal you want to achieve?
The goal is to making sure, at least for, I mean, let me be clear, for executor containers. For any executor container, I want to making sure that regardless what the container is doing, they cannot write the infinite amount of data onto the disk.
Okay. Are you guys using like custom executor?
We are not yet. We plan to write one.
Okay.
But I don't, because if hello?
Yeah. Hey, yeah. I'm here.
Yeah, because regardless of default executors or custom executor, if you launch a Docker image right now,
yeah,
as long as you find as long as the RESTful path that's not mounted, it would end on the root file system.
Yeah, so I guess I'm curious why like you're limited to just executor containers, not all the
Oh,
containers.
no. Okay, let me drop it there. I think executed container is really urgent. We don't have nested containers. Yes.
How do
Okay.
you guys launch tasks right now? Are you using command executor right now?
We are. It's a mixture. We use both thermals, command executor, and the default executor. We use
I
all of
see.
them in different setup.
Okay, got it. Okay, I see.
Actually, let me just make it a go then. This should work for both executor, container, nested container, and standalone container.
Yeah, all the containers. Okay, so that's okay. So that's clear. Okay.
Mm-hmm.
Okay, so the other thing is like what Docker does right now. You know?
Docker doesn't do anything.
Okay.
Which is the so this is the kind of the really, I think this is the last piece of thing that requires operator intervention in our cluster on the isolation stack. CPU memory noise is annoying, but they kind of handle differently. But kind of disk space leak is problematic. We kind of on average have one happening per month, which makes a machine unusable.
I see. Okay. Okay. So this actually is the the kind of the writable layers of a container, like not part of the sandbox, but like somewhere else in the cluster in the image.
Right.
Okay. Sounds good. So Nungo is making RealFS read only. So you guys cannot do that?
From my experience right now, this will force us to re-audit every Docker image we have. And
I see.
Because, for example, if the user it's very often that, for example, I build a Docker image using a third-party library. Usually the creator of the image will not audit every line of third-party library, say where does it log, or create a temporary file, all these things.
Yeah.
We don't know that either. So, and if we make this read-only, the thing will really fail much later in the process.
I see. Okay. Yeah. I see. Got it. Okay. So can you scroll down?
Yes.
So what's the
I guess we can skip the background part.
Yeah, I think we could just ignore the background part.
Yeah.
So one quick question. So the limiting the rootfs size here, it means either when we provision the root file system, it cannot exist a limit of the user set, or after the rootfs preparation finish, the container cannot exceed that limit. So I'm still a little confused on these two parts because I missed the first conversation.
I'm not very explicit on this part right now because I think whatever the rootfs size uses after the provisioning, but before we start the process, that typically is okay. Like I haven't seen that causes trouble in any practical environment, because that's at most that's not going to be bigger than the Docker image size, which we typically track at the build time, or at least they're pretty easy to know. But after we get the image up, and whatever the process is doing at this point is out of control of us.
Okay, so the limiting here, it means like it limit what the container process write to the disk.
Yes, although if we're using copy, because the provisioning part also takes space. So for all the other three backends, the provisioning itself does not create extra disk space during provisioning. The image itself occupies space, but it's calculated separately, I guess.
Okay.
Yeah, so I think I feel like we probably need to do this in a backend specific way, because I think for copy backend, you do need to limit the size for the entire provisioner rootfs, because that's kind of private to each container.
Yes.
While for overlay, the part is actually the upper layer, because the lower layer is actually shared. You cannot like limit the size for that. Like how do we account for the size for that? I don't know. Maybe like it's
I don't know.
Yeah, I don't know. Like maybe it's better to like also account for the lowest level. I mean, it doesn't make sense to, yeah, I don't know what's the best policy for overlay because it's really like a shared layers. Like I think we can conservatively assume that container or executor has to declare resources for those space as well.
It's interesting. Like we have at Uber, we have two type of cluster. Our service cluster, the layer sharing is not aggressive. Like between different images, they share maybe I'm making less than half of the layers per size. However, in our batch cluster, we probably launch one Docker image for all the tasks.
Okay.
So if we and it's a very big image, but there's only one copy on the machine. So if we charge this to the container, the amount of the disk calculation is definitely seems too conservative.
I see. So you're saying like in some specific workload, that calculation might be too conservative and doesn't make sense.
Correct.
Okay. Yeah, I think we probably need to design some like policy there. Like one thing, like we can just cap the upper layer size. So that's one policy. The other policy is like just cap the entire thing. Depends on whether the user wants to be conservative or not.
Yeah.
And then we should let the operator choose which one to use, I guess. Yeah. Okay. So do you have a kind of a design? Like what's the kind of the design?
So I guess this is just like two high-level directions. One of the direction is to provision these mutable paths in the sandbox.
Yeah.
Because sandbox is the directory that all the disk isolators is closely tracking. So if we just provision, I believe if we simply provision all these mutable paths there, we can achieve something pretty fast and also both disk related isolators can just track their size and report. It can also report. I believe it can report both numbers as reports both the sandbox size and the root file system size as a sum number.
Yeah. So yeah, this has okay. Yeah, I understand this part. So yeah. So I think it might be complicated because the way we do bind mounts for rootfs and sandbox, because we really like bind mount the sandbox itself to the rootfs. So did you see what I'm saying? It's kind of a cyclic dependency. That the sandbox depends on rootfs. Then right now currently, so the sandbox does not depend on rootfs, right? The rootfs does not depend on sandbox. Oh, sorry, the reverse. So rootfs does not depend on sandbox. But you're then adding this dependency because the upper layer is inside the sandbox. So the rootfs essentially depends on sandbox, and sandbox depends on rootfs. So there's a cyclic dependency. So it might not work.
Yes, James P. is not here, but he actually suggested we create a parallel structure. Like for example, change the current leveling, say move the actual sandbox one level down, and then create a parallel layer of the root part. So the sandbox and the root is, so I believe right now the sandbox directory is something like / framework ID, execute ID / then runs, and then a UUID. I forgot what that UUID is. Is it container ID?
Yeah, so UUID is the container ID.
Container ID, then we treat that container ID as a sandbox. Maybe we can probably do one level down. So one of them is actually create a /sandbox and then /root. This is the name he's picking, but then we still track the UID part.
I see. Yeah, so the complication is you do have an image volume, which I don't know who is using that, but we do support that. That essentially for each container, you might have multiple rootfs.
Is that rootfs also writable?
Yeah, so that rootfs is writable. It's the same rootfs as if it was the so the long story for that image volume is we used to plan to use that to support thermals because thermals wants to shroot themselves. So but they don't want to prepare the RFS by themselves. They want Mesos to prepare the RFS for them, and then they can shoot into that RFS. So then that's the reason we add this image volume thing, where we use the same provisioner to provision a RFS for the container. So there might be multiple image volumes, which is useful in general. I mean, for debugging, maybe, who knows, like maybe in the future it might be useful.
We have a pretty interesting potential case because we have been heavily invested on Docker image distribution.
Yeah.
We are generally thinking, can we just wrap any arbitrary kind of binary data as one fat layer above a base image? And then we simply provision a new image volume every time we need to distribute some kind of large data.
Yeah, so that's one potential usage for that, for sure. Yeah, yeah, it goes through the same provisioning steps that we saw for the RUFS. Yeah, so TLDR for this is having a root inside the sandbox directory might not work because we do have the image volumes that will use spaces.
But
and do
can
want
we
to
also
account for
provision these image volumes there?
Yeah, we can. I think
So
that's a big change.
Yeah.
Okay, maybe we should go through all the design, like all the alternative first before we kind of thinking which one is the best. Now, I understand that you want to have a, I think this might be something we want to do because I think this is just something that we regret that we didn't do initially, to have a subdirectory for just sandbox in the work there for the container. Sorry, for the executor, right? So. This is just something we regret that we haven't done, but right now it's hard to change, I guess, just for backwards compatibility.
I'm also concerned about the migration overhead, like the code needs to handle, because the code needs to handle both cases of how the sandbox is provisioned.
Right. Yeah. Okay, so what's the alternative?
Alternative is simply like, I haven't really expanded how to do this, but it probably means we need to send more information to all both disk isolators and say this. I think right now the isolators only know the root file system path. It does not really know anything about the backend or how this is done, but other related.
Right.
But
but I think that we can get the back. I mean, I think we can get the root FS directory for each container, right? That's something we checkpoint already, do we?
Yes, we do.
That's part of the container config that you already checkpointed. But that's the provision, but it's not the upper layer, I guess. What you really want is the upper layer, not the entire RFS.
Right, exactly.
Well, I guess if we do the policy that we be super conservative, then it's okay. Then we don't have to get the upper layer. But if we want to just do that for upper layer, then you have to somehow get the upper layer. But that's backend specific knowledge.
Right.
I see. So yeah, that's the tricky part.
So I guess the question here is, do we want to open up these backend specific informations to isolators?
Yeah, we can. Why not? I think that's. You mean backend specific? Oh. Yeah, I mean, it's more like which backend you're using, and then there's some helper function in the backend that you can directly call. You don't have to know the detail. You just need to know to call that function. Like, I mean, maybe generalizing the interface, say, hey, these are the disk space. These are the directory that whose disk space might be counted towards the quota of the container. Things like this, and then return. Ask the backend to return a list of directory or just one directory that you can actually do a DU in that directory.
So isolator can query backend to know. Yeah, I think the new, I think the interface, this part sounds a good idea. Is this actually new? is this ever mutable after? Can this information change after a container comes up?
No, it's there, right? So I don't think it can change after containers up.
So there is not going to be new paths that needs to be tracked after the isolator called
Started. Yeah.
Started.
Yeah. Well, like the only thing that's that might be mutable is volumes, like persistent volumes that you can add after container is launched. But I think the tracking of the size of persistent volume is already handled by the isolators.
And it should handle different. It should not be counted in this part anyway. Since
So this is more like the sandbox usage, right?
Yes.
So
Yes.
Like a private usage for each container. It's not like volume. So in that sense, the image volume should we do that separately or? Image volume is really interesting. I feel like implementation-wise, option A, if we can make it work, is
I actually got incorrect impression that image volume was read-only until this meeting. I used to thought the image volume was read-only.
It's not read-only. You can actually write it.
Okay. Also, is Thermos actually going to use it?
They plan to, but I don't think they're using that right now. I don't remember. Because
why don't they simply move to nested container?
Well, they can. Just like they need work to make that happen.
But it seems like equivalent amount of work at this point.
Okay.
Yeah.
Can you scroll up a little bit? I need to think a bit on the first option. So what James P just said? Can you
see the comment?
Task container directory get the disk resource applied, but container sandbox is the sandbox. Is the overlay layers. I see. Yeah, so this might work. So this is basically for the upper layer.
I guess we can even expand the /root part to put not only the root file system but also the image volume. We can also put the mutable part of image volume there too.
So anything that's private to the container should be put there.
Yes.
Basically.
Yes.
Yeah.
And I think this design leaves a further space of if we do other things, we can just add one more parallel level there for future things because all the disk is tracked on the container ID part. Yeah,
so that's a fundamental change of the layers. Like, what about nested container? Are you going to be storing the sandbox under root containers sandbox or sandbox container ID sandbox?
Where do we put it right now?
Right now, there's only one sandbox for each container, right? So,
yes.
And then we have a containers subdirectory under the sandbox, and then container ID, and then that would be the sandbox of the nested container.
I see. So
yeah, it's all merged into. So if we want to split these two, which I think we should do, like it's just like backwards compatibility story is hard.
Yeah.
Let's say we have two. Then you can have anything that's user visible should be part of the sandbox directory. Anything that user should not see is part of the root directory.
Right.
And then you maintain this parallel structure for each container, even for nested container.
Right.
Which you can definitely do. Yeah, I think that's possible. Just backwards compatibility story is going to be hard. Yeah, I think it's more doable. For the second one is more doable. I think the backwards compatibility concern is I don't know how to solve that.
Yeah.
Unless you just tell people to drain the entire box, delete all the sandboxes.
Okay, I think this pretty much concludes it. I didn't have any write up about the standalone container because when I wrote this, it has not been landed yet. So actually, how is standalone container? Does it have a sandbox?
Yeah, it's the same as but the sandbox directory is not under slaves work. It's not under like the traditional like sandbox for executors. It's just like top level slave worker containers and then container ID.
So that's the sandbox, and right now the root file system is still in the provisioner.
Yeah, so right now all the rootfs, including the upper layer, is part of the provisioner.
I see.
Yeah.
But,
So I think one thing that like if you don't want to do this like a per backend thing, like you only do that, like say just make sure the entire RuFS is under CRODA. You can just run DU on the RuFS directly.
we also want to move away from DU. We also are looking at moving away from DU slowly into either XFS or maybe port the project quota thing onto ext4 when we upgrade the latest kernel.
Then you can like for like XFS, you can just like assign the same project ID for that upper layer to just use the same project ID. Then it will be subject to the same quota.
Yes. Well, yeah. The reason is like DU does not. The reason we want to do that is DU has the limitation that it does not know. It does not track files which are deleted but still being held, but still has its handle being held by something. Like if you have a file that's deleted, but there's still another open file descriptor by a different process, DU does not see it.
I see.
Yeah.
Yeah. I ideally, yes. Ideally, we should probably just use XFS or some other ways to make that. So that means like we only have one option. Just put that. Well, otherwise you have to make sure DU can understand the structure of the provisioner. Yeah, I think the long-term direction. I agree. Like preferred design is actually something we want to do long term if we can have a backwards compatibility story.
Okay.
Yeah, maybe we should spend some time thinking about how to do that. That's something worth thinking about.
Yeah.
How to do that. Okay.
Okay.
So what's the timeline for this?
Well, I guess this is not going to happen on 1.5. So maybe I want to target to say if we can have some mechanism in 1.6.
Mm-hmm. Okay. Yeah. I see. Okay. Yeah. Okay. We can. Yeah. I'll probably need to think about that a little bit more, and I think we should spend some time thinking about the preferred design because I'm pretty sure how to do that for the alternative design. It's just pretty hacky.
Yeah.
Yeah. I think the rule of thumb here is like anything that's private to the container should be part of the container's ephemeral disk space, and that disk space is part of one single directory, so that's much easier to track. Yeah, I think that makes sense.
Okay. I guess this concludes my part.
All right, so I think I don't have anything else for this working group. I plan to have a demo for standalone container, but I think we're too busy that we don't have time to prepare for that. So maybe next time. Yeah, I think things like next time I'm gonna send out an email early, and then we probably need to go through the priority list of things that we want to do. I think like right now a lot of things are finished. And people are working on something new, and then it's time to update that spreadsheet and see what people are working on right now, and then what's the plan for the next 6 months, things like this. All right, I don't have anything else.
I do have a couple of quick questions, especially after standalone container. The first is, I think we still plan to build some introspection API to list all these containers and then know their configurations, right?
Yeah.
Is that planned to be in 1.5, 1.6, or somewhere? Yeah,
so that's what we plan to do. I hope to get that in 1.5.
Okay.
We basically augment the get containers operator API to allow operator to list not just the normal containers, but also the standalone container as well as nested containers. Because right now the get containers only show the top level executor containers.
Yes. Can you CC me on those patches once you have them?
Yeah, sure, of course. Yeah, I'll create a ticket. I don't know if there's a ticket for that. So Gilbert, I remember there's a ticket for showing nested containers.
I also remember there's a ticket.
Okay. Yeah, I probably requested that.
Yeah. We should definitely do that.
Yeah.
And we probably just allow people to specify some parameter in the operator API. Say, hey, show all the containers, or just show nested container. Just basically a few filtering stuff.
Yeah, after the checkpointing, I think it should not be hard.
Yeah, I think even before checkpointing, it's not hard. Anyway, so yeah, I think we should do that. It's not that hard. Just adding some implementation there. Yeah, so that's the plan. That's the plan to add those. I think what we do right now is that we can kind of for the standalone container stuff, we kind of combine like so the launch nested container API will be deprecated in favor of just launch container, which can launch both nested container or top level container. So that's the change we did. But the old API still works. It's being deprecated. And then we use the container ID to tell whether this is a top-level standalone container or nested container.
So another question is about the security, like especially for the default installation. I don't know how many people actually set up the entire credential ACLs on their agent side. So this is actually not super trivial to set up, because in the cluster turn up, agent is almost always the first element you get up. And the dependency of the agent to other security or secret distribution system is often tricky. So honestly, we don't have any secrets or credentials set up on the agent side.
Yeah, so
this kind of
what we do in DCOS, DCOS is like they have a centralized server key management server that you can hit to do authorization authentication. But the default one is actually based on some file on the local host. Right, so that's not well. I think I remember we used to do like just have Puppet or Chef to populate those keys and then make sure they're protected by root user. That's what we can do.
So I think the reason I bring this up is after nested container and the standalone container, there's actually an extra attacking vector in the agent part. Before these two APIs, actually people cannot mutate the state of the agent through agent API, I believe. These are the two, this set of
but we add the authentication authorization too.
Yes, but I guess for default installation of a Mesos agent, which people don't set up credentials or ACL.
Yeah, but you can set up ACLs to just disallow any user. You just set up, I mean, that's just an agent flag, right?
Oh, so you mean people can just simply set up ACL and say, ban any image to launch within these two containers?
Yeah, only allow one particular user to call those APIs, one particular principal. But you have to set up both authentication and authorization. Yes. So for setup authentication right now, I think you can use the basic auth, but that means you have to save some credential file on the agent node, which is a little tricky. You have to distribute the key to every single node.
And rotating it actually is a bigger problem. And
key rotation is hard, yes. I don't know what's the better solution for that, but we do add authentication authorization for that. So,
I mean, if we look at other systems, like what Docker is doing is that the default, this part of API only listens at a root, equivalent root on the domain socket. So the caller part needs to have equivalent root permission to actually call these APIs.
Yeah, but that does not work, right? That means like everyone wants to use the API has to have root privilege, which just probably doesn't make sense.
We can definitely expand this. I'm just saying that's the default behavior of the Docker, like what you get out of the box when you install this without extra configuration.
Right. So that's one good point.
Which seems a little bit slightly safer than what we are doing.
Yeah. I don't know what's the best way. I think Greg is on the line, but I don't know what's the best way to solve that.
Yeah, I mean, I personally, I don't think I care for the idea of protecting that API via file system permissions. Seems better to me to have a consistent authority for authorization.
You guys can write a module if you want to.
Yeah, I think the default implementations in Mesos are pretty simple, but the existing authorization should allow you to wall off any APIs or restrict them to particular users.
Yeah, I think authorization is okay because that's just some config file. I think that the credential part is hard, but maybe you guys can use a custom authentication, like hook up with LDAP or kernels in your environment by writing a module. so that every call is authenticated, whether it's authorized or not, like depends on the flag, and that flag is easy to distribute.
Yes. I think we are going. We probably will do that sometime in the short future. I just feel like we probably want to enhance this a little bit for the default installation methods.
Yeah. So that I can tell you what we do in Twitter. Like we just use Puppet to distribute those keys.
We are doing the same thing. It's just we are having hard requirement of not depending on another system and bring up Mesos agent.
Oh, you mean Puppet? But you need to have.
We can use Puppet, but we cannot. The dependency to a secret store is very unclear right now.
I see.
Because of a cluster turn-up process.
Right. Yeah.
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 So Jita, just to clarify, does that mean the difficulty is that it's not clear that Chef would have access to the relevant keys, to the relevant credentials that you need?
Yes.
Okay, gotcha.
Yeah, you guys should write a module if you want that. I think that's the only way I can think of right now, because you have special requirement for, I think most people, like for default, they don't care. People cannot log into agent box anyway. And then it will be firewall to a given, I don't know what can we do in firewall to prevent people direct hitting agent API.
Yeah, that's on a per endpoint basis. So if you have a single endpoint you want to wall off, that'll work.
But can we do that for a single operator API? Like I do want people to get flags, but I don't want people to get like launch nested container or launch container.
No, the firewall flag in particular doesn't get that granular.
I see. Yeah, maybe like this is something we could do, that have some, at least disable some endpoint on per call type rather than per endpoint.
We could, but I think my question then would be, why don't you just set a strict ACL that doesn't allow any user to perform that operation?
Well, I think just ACL doesn't help, right? I think the tricky part is setting authentication, not the authorization part. The ACL should be pretty straightforward to set up.
Yeah.
Yeah, but I guess if you're saying you want a particular operation within an API to be walled off, then that implies that you want people to be able to authenticate. Like walling off that, just setting an ACL is sufficient to prevent anyone from accomplishing that.
No, I think you need authentication, right? Otherwise, I can just pretend to be root, and I can do everything I wants to do. Or you say like set an ACL to disallow anyone to use that endpoint.
No, not the endpoint, but the operation.
Oh, I see. Yeah.
You could disallow all users from performing a particular action.
I see. So that's just disable that API.
Right.
So just how you can do that. You can just, if you don't use that, then you can just disable that API. But I think the executor wants to use that. That's the tricky part. But I guess we have for that. Maybe just bypass this. Is that correct? So I think the implicit authorization will override the default ACLs.
Yes. Yeah. Yeah, that's
so basically
the case.
The executor can still launch nested container, but any operator cannot do that.
Yeah.
Okay.
Yeah, if you're planning on going down that road using the ACLG tab, then we might want to look at the code and just confirm that the implicit executor auth is going to work for you there. But I think that would do the trick.
Okay.
Yeah, you can set up an ACL to just basically disallow anyone to hit the endpoint, that particular like launched container or launched nested container. Yeah, I think that's one thing you can definitely do to prevent anyone like accidentally hitting that API. But that also means the operator cannot use that API.
Okay.
And so that's just one safety net. The true fix is you set up the authentication module properly so that you can set up the ACL, say, hey, only root user can use that. Otherwise, anyone else cannot use that.
Yep.
All right. All right, sounds good. Thanks, everyone. I think see you guys in 2 weeks.
Okay.
Later, guys.
Yeah, bye-bye.